Hi everyone. I was reading the Year 12 exam report here in Western Australia, and one of the comments it made was that students poorly calculated the equation of a straight line. So I'm just going to go through it again. I can get any 2 points, and between any 2 points I can get the gradient, and the gradient is a measure of how steep the slope is. I like to talk about if you've got your left arm going up like this one, that's a negative slope, a negative gradient. If it was that way, it's a positive slope, positive gradient. There's lots of different ways to talk, but that's my preference, and when I nag students about it and I want them to get the idea, I prefer that way. But if we want to calculate the gradient, the formula for a gradient is y2 take y1 over x2 take x1. I still say to everyone, one of the quickest ways to save yourself making silly mistakes is to put x and y, then put the ones and then put the twos. It saves people mixing up. Amazing how many people put the numbers in the wrong spot. It's just so common. So then you can go, I need a y2, which is that one there, 1. I take y1, I subtract the y1, which is a 3. And then I can go to x2, which is the 4. And I can subtract the x1, which is the 1. And I get a gradient of -2 on the top and 3 on the bottom. So it's a gradient to the, I call it to the left, going up to the left, and it's a 2 on 3. So if you looked across here, you could have a quick look here, and you could just go 1, 2, there's the cross 3. We talked about that as the run 3, or a cross 3, and this one here is a rise of 2. So you've got a rise of 2 and a run of 3. Always bothers me though, because I know when I teach a lot of students about rise over and run, that they still muck it up. So keep thinking of this idea of it, left arm, right arm, and using the formula, and you've got -2 on 3. Now when we talk about the equation of a straight line, there's one basic formula, and the formula is y equals the gradient x plus, now some people write c, some people write b, I'm going to write c at the moment. Some people write c for constant, so it depends on when the equations get more complicated, there might be other letters that people use. Let's have a look at what we've got here. What does this have to do with this question over here? It tells us what the gradient is. We don't use g for gradient. I think historically it's probably because g was used for gravity. So we're looking at g for gradient there, and m for gradient, and I've got -2 on 3 of x plus c. You can see how this gets pretty revolting with the fractions. How can we work out what the c is? If I know an x value with its corresponding y value as a pair, for example that pair, or I could use that pair, it'll tell me what c is. And what's c? It's the y-intercept. So if I go up to the graph over here, if I actually had a straight line through, it would tell me where that straight line is passing through the y-axis, which we call the y-intercept. So I'm going to go here now, substitute. Old school, we'd always have to write what we did, substitute, and I'm going to go 1, 3. So I'm going to replace the x by the 1, and I'm going to replace the y by the 3. So there's the y, so I replace that by the 3. Got -2/3 multiplied by, remember there's a multiply there, and the x is a 1. Plus c. Now I can work out what c was. I deliberately made it fairly horrible numbers because it's not always that obvious what the numbers are, and it's fairly common what you can do in exams and tests. So now I've got a 3 equals -2/3 plus c. I want the c by itself. How do I get rid of -2/3? If I add +2/3 to this side, add +2/3 to that side, that's what I call opposites to both sides. Opposite to both sides, and the opposite of -2/3 is +2/3. And you end up with this c equals 3 2/3. So let's go back to the equation. Back up here, go back to what we said for a moment. First we have to get the gradient. Could read it off the diagram, or you can use the formula. That's that number there. Then we need to figure out what the c is, and the c is where it crosses the y-axis. So you can put in an x value, you can put in a y value. You can't use that x and that y, you need to use this pair or that pair, and they'll both work out the same to 3 2/3. So now the equation is actually y equals -2/3 of x plus 3 2/3. So if I looked at my diagram up here, it was hard to tell that it would actually go through here. There's 2, there's 3, there's 3 2/3, so it will go through that point about there. So I could put a line through it. Interesting part is in exam questions, sometimes we'll give you a part of a line. We won't necessarily talk about the 2 points, but we'll talk about that line, for example, that goes through there, and talk about, we don't even say we need the equation, it's just that you need to realise that we need the equation. That's one approach. There's our first one. That goes back to the basic formula. If I take a second approach, or a second method, there is a third method, but we're not going to do that today. Just the 2 most important ones. The formula is y minus y1 equals mx minus x1. I could talk about that, but I want to keep the video short. Let's have a look what happens this time. I still need the gradient, and I need an x1 and a y1. So this time they actually tell you in the formula, for example, there's x1 and y1. So you wouldn't have to think about which one. By the way, it wouldn't matter which one you choose, but you don't have to think. So that's a little bit more of the non-thinking approach. Probably myself, I'd do this without thinking when I was a student and just went through the motions. So here we go. Y is, for example, in the formula, we want a y. Now we want to subtract a y1. We can go to our y1 there, which is 3. We can go to the gradient, which still gets calculated the same. So you still need to calculate the gradient whichever way you go. Minus 2/3 bracket, there's the x, and this time we use x1, which is 1. So basically there's the equation of the line, but we need to do a bit of the fraction work, and this is where people come unstuck. Also reading the same exam report, it said a lot of students did fractions poorly, even at the year 12 level. It's so common. So that's why I talk about it and talk about it. Remember, there's a multiply here, so we're going to multiply those two, and we get minus 2/3 with an x. Now I'm going to multiply these two. There's my eyebrow method to keep track. The 2 negatives will become a positive. One rule, 2 negatives become a positive. And you've got 2/3 times 1, which is 2/3. So if you had trouble with that, 2/3 times 1 is just 2/3. So 1 times anything stays the same. And again, we've nearly got our equation done. So it's in many ways a lot better because you don't have to think, but you have to be careful with fractions. This time I want it to say y equals, so I need to get rid of the minus 3. How do I get rid of the minus 3? The opposite of minus 3 is plus 3. And if I add 3 to this side, add 3 to that side, and what am I left with? I've got the same equation as before, minus 2/3 x plus 3 2/3. And there's your equation of your line, that way. Now, this was made worse because this is horrible, that it was 2/3 and it was a minus 2/3. If it was going the other way, it's a little bit easier, we don't have the negatives involved. But it's always your choice which way of doing it. But, you know, they could have another line going from here to up to here somewhere. We could figure out the equation of that line as well. And what would we use? In this case, I've got a 4-1 and I've got a 5-4. So this method would be nice because all I need to do is substitute the 5-4 and work out the gradient, and it'll be a lot simpler to do, I still think, than this one. But that's handy at times. I hope it helps.